All right, and again, as always, I think we're just going to start off from where we last left off. So this is the next page. And again, don't forget, quizzes are largely extra credit for now. Okay, I just don't think with the summer course we have enough time to fit in quizzes in a standard way. You know, because usually with the quiz, you're supposed to like cover stuff, get some time to understand it, practice it, then use the quiz to show what you've learned. But it doesn't really quite work out as well in a summer course. So again, I'm just going to make them extra points. So you don't lose anything if you don't do them, but you will get some points if you do them. All right, so this is just a quick recap of just some of the things we've covered. So vertical angles, linear pairs, just a couple of the other definitions and things that happen. And I guess I'll just go over them really quickly. So vertical angle, so two angles across from each other on intersecting lines are always congruent. So they're, you know, like in this case here, it says angle 1 is congruent to angle 2. So they're both across from each other. And also in that same set of lines, angle 3 is congruent to angle 4. So top one is across from the bottom one, and that means they will be congruent too. Linear pair, so I'm just gonna go like around, you know, clockwise. Linear pair, two angles that are adjacent, so remember adjacent means next to each other, and supplementary. Supplementary means adds up to 180 degrees, and I think on the first day I looked up like supplementary, and actually I don't remember what the definition was, something like completes something. All right, so this is kind of like completing a straight angle. And that would just mean it forms a straight line. So measure of angle 1 plus the measure of angle 2 will come out to 180 degrees. And very similar to that is supplementary angles, any two angles whose sum is 180 degrees. Now, what's different about these two? Because you would think that they both equal to 180 degrees, so why are they different? Well, in this one, it says adjacent, which means they have to be next to each other. Supplementary angles don't have to be next to each other. They can be, they could be, you know, different. Let me just make an example really quick. I'm trying to practice some of these tools. Like if I had a line like this, you know, if I had an angle like that, then I had another one, something like this, and it's probably not going to be perfect. All right, but you can kind of imagine that if we were to take this piece and turn it and fit it into this lower piece, it'll probably make a straight angle. It'll probably make a 180 degrees, but I have to move it so they're not adjacent. So if supplementary angles do not have to be adjacent. All right, complementary angles. Complementary angles, complementary means it goes nice with each other. So like if you go to a restaurant, sometimes they'll give you like complimentary bread or something like that. Or I know the word's used a lot, especially like I think in hotels or something, but it just means like, okay, it's nice to have a mint with your dinner or something like that. I think Olive Garden is the only place I know of that still does that. Most places usually just cut that out. But there's things that go nice with each other. I don't know, like peanut butter and jelly. Okay, so I know some people will eat those on their own, but for some reason they just go, like when you think of it, they just have to go together. And that means 90 degrees as well. So it's kind of the same thing, just 90 degrees. Adjacent angle, maybe it might have been better if I had gone this way, you know, counterclockwise. Because adjacent angle, we already covered that. That's just two lines that are next to each other. And it also means that they share a common side. So just like a classroom, you know, I have some teachers in my classroom that are adjacent to my classroom. Wait, they're not in my classroom. They're adjacent to my classroom. That just means they're like right next door. We share a wall, right? So share a wall. Anyway, so I guess that's it for this one. Let's move on to the next one. And this one's just sort of a checkbox thingy. I'm not sure if you can see the top part there. It just says identifying types of angles. So check all the relationships between angle 1 and 2. All right, so what are these here? So we have a couple of options. Well, they are not adjacent because they're not next to each other. They are vertical because they are on opposite sides of the intersection. They're not complementary, not supplementary, not a linear pair. So in this case, it's not multiple choice because with multiple choice, you pick one. It's actually more like, what do they call it? Check all that apply sort of thing. So in this case, there's two answers here. They are adjacent, angle 1 and 2 are adjacent, and they form a 90-degree angle. Now, if there's a 90-degree angle on this side, that means these two are also going to be 90 degrees. And we don't know what it could be. One could be 50 degrees, the other could be 40 degrees. Maybe. Okay, I'm just guessing. But they end up adding up to 90 degrees, so that's why they're complementary and adjacent. All right, let's move over to this one. So they are supplementary, they are a linear pair, and they're adjacent. All right, so they're not vertical because they're not across from each other, and they're not complementary because they're not 90 degrees. This one might be a bit of a tricky one because while they are adjacent, you might think that they would be complementary, but that looks a little bit more. I mean, if you tilt your head, yeah, that's going to look like, it might look like 90 degrees at first, but it's not. So that one's kind of a tricky one because there's only one option. All right, let's see what's going on with this one here. Number 5, well, we can see that these two things, the angles here, so the angles forming this upper right side are, well, it's a bisector, so we know they're the same size. Maybe that'll come in handy. All right, so again, we have an intersection, and 1 and 2 are across from each other. They're opposites, so that means they are vertical. And we know that this is 45 degrees, and this is 45 degrees because both of them must add up to 90 degrees, which means this is 45 and this is 45 degrees. So that would mean even though they're not touching, they still make up a complementary angle. And again, they don't have to be adjacent to be complementary or supplementary, meaning they don't have to be next to each other. They can be opposite directions. They can be facing in nowhere near the same directions or completely different directions, all right? They will still be complementary. All right, number 6, vertical. So they are across from each other on an intersection, so they will be the same size. Supplementary. So supplementary, well, this one's not, if this is 90 degrees, it's telling me this is 90 degrees, which means the opposite is 90 degrees. And that would mean this is also 90 degrees because if you have straight lines, they have to keep crossing at that same angle. So all 4 of these are 90 degrees. Now, if this is 90 degrees up here on angle 1 and angle 2, also being 90 degrees, well, that means that they are going to be a supplementary set of angles, meaning that if you put them together, they will make 180 degrees. Okay. Let's go ahead and move on from there. And I think for this one here, I have the slide ready for this one here. So I'm going to move over to that part. So you can see it's the same problems. Again, I just, I don't really have a whole lot of time to put these together. So I wish I could make these a little bit better. But again, we actually don't have prep hour for summer school because we have Zooms like all morning. And then we have we kind of have that 40, 50-minute break. Yeah, it's about a 50-minute break. And there's not really much I can do because I'm supposed to be in the classroom, still in the Zoom class and helping people with homework and stuff. But yeah, it's not quite gonna work out. For me, I don't have enough time to put the slides together, but this morning I got in kind of early and started putting this together. So how long are we going till here? All right, so it looks like we got about another 30 minutes. This is actually kind of moving a little bit quick. I think we might actually be done a little bit sooner. Or maybe I'm moving too fast. I don't know. If I'm moving too fast, let me know. All right. Okay, so let me get started with these now. All right, so directions are find the missing angle in each figure and keep angle relations in mind. So we still have a couple of those things, right? We still have all of the ones from that wheel that we covered earlier. Oopsie. Wheel, where did we have it? Right, not that we really, oh, it's not on here. Okay, I just copied the problems. But things like the supplementary, complementary, linear pair, vertical angles, and adjacent, we gotta keep all those things in mind. All right, so let's see, number one, top part is 112 degrees. Well, since they are vertical angles, they are gonna be the same size, and that's just one of the things that always happens, right? So it's kind of like a rule. In this case, for this one, X would be 112 degrees. They're just gonna be the same size, right? They're gonna be congruent. All right, let's see, moving on to number two. For number two, what do we have here? Well, we have a larger angle, which is the, it's the two added together, both angles put together make a 90-degree. So since they're a 90-degree angle, well, they have to add up to 90 degrees. Now we have two angles. We have the smaller one that they just call X, and then we have this larger one, which is just called 68. So how much would this be? Well, we could also use angle addition postulate, which is something we covered yesterday. And an angle addition postulate, remember, it means if you add up these two, it's gonna add up to the angles together, which in this case is this one here. We don't really name them. Sometimes we don't name them. Like yesterday, we were talking about the angle like E, F, G, and F, E, K, and stuff like that. But here, let's go ahead and do that. So we're gonna have to do a little bit of work. So I'm gonna need 90, because I know this should come out to 90. And then that's if I add X and 68. Do a little bit of algebra, minus 68 from both sides. Luckily, we don't have a lot of steps to do. And I'm pretty sure I know what this is, but I'm gonna play it safe today. Minus 68. That'd be 22 degrees. And I'm gonna flip the sides so that I get 22. And I'm gonna put a box on it. In fact, I should have put a box on the last one too. I'm gonna go back and do that right now. Just because that was the only thing that I wrote there. And over here, that's gonna be the only thing I wrote here after all of this work. So I don't want that to get lost and mixed up with the work. So there you go, I boxed that part here. And that's the way I do things. I like to box the answers. I should have said that. I think most people kind of understand, just seeing how I do things, they see that I box things. So I guess I should just say that right now. All right, what do we have here? Ooh, excuse me. Came out of nowhere. My room's not dusty or anything. Anyway, so this should come out to 180 degrees. As I was saying, they're a linear pair, and they would also be supplementary. Supplementary means it adds up to 180. So I'm going to do this one a little bit different. I'm going to add the small angle, the large angle, and that should come out to 180. So this 180, it doesn't say it anywhere on the diagram, right? It doesn't say it anywhere. That's something that we have to know. That's something we have to bring with us to this problem. So sometimes I know it looks like a problem might be unsolvable, but sometimes you are expected to know a few things before going into them. And I'm going to get rid of this 124, right? Do the opposite or the inverse operation. And 180 minus 124. And that would be 56. And oh yeah, in degrees, we got to put degrees in there. It's a small thing, and I think if you miss a couple of them, I'm not going to really care all that much. But always put the unit measurements in whatever you're measuring, because it's like what, 56 what, 56 inches, 56 centimeters. You just got to make sure you let people know what you're working with. So anyone who reads this can say, oh, okay, they're talking about degrees. Plus that it even has a degree symbol right there. So anything you put in there is going to have that degree symbol. All right. So that looks like these top three were kind of the easy ones. Let's move on to the next ones here. Find the missing measures in each figure. So it doesn't say find X, because if it said just find X, we could probably get this one. But it looks like we're going to have to find all of them. So let's go ahead and do this. I'm going to put kind of a couple of them. So X equals, Y equals, and I'm going to leave a space in there because I'm going to put some numbers in there later. Z equals, and that should be it. I might just put a little box already together. Kind of hard to draw a straight line sometimes. Oops. Okay, close enough. Just to clean that up a bit. I don't usually draw boxes that big. All right, so let's fill in what we know. So 43 is what we know. We also know that vertical angles, or angles, again, directly across each other from the intersection, are going to be the same size. So we already know that this is going to be 43 degrees. There you go. We're off to a good start. Now, if you look here, I have a linear pair if I join these two angles, and I also have a linear pair here. And so if I'm going to do the top one, I don't know if, you could do the bottom one as well, but I'm going to do this one here. So I know that that angle adds up to 180. So I'm going to kind of cut out the short step, because instead of writing the whole thing out, I'm going to say 180 minus 43. 180 minus 43, and that would be, that's not right, 180 minus, and that would be 137. So 137 degrees. And that would also make this a vertical angle to Z. So X and Z are also vertical angles, which means that they will also be the same. They will be congruent, so 137 degrees. So I didn't have to do a whole lot of math for that one to get all of them. All right, now it looks like it's gonna get more and more complicated as we go through these. So let's see, number 5. So we have X, Y, and Z again. And I'm gonna go ahead and put it down here. X equals, leave a space, Y equals, leave a space, Z equals. And this helps us kind of, organize which one we should look for next. All right, so let's start putting things together now. Let's see, what could we find? So we're trying to get all of these pieces here. So we start from what we know. We know this is 72. Now, if we know this is 72, we could probably get X. But let's go with something even easier. It looks like we can see that these two things are vertical angles, so they're right across from each other. So that would be 72. And either way I look at it, this is a linear pair. This is a linear pair. So they're always going to be 180 degrees. So I'm going to start with 180 minus 72. And it doesn't matter which one I'm working with. I could be finding it from this side or from this bottom side here. And 180 minus 72. And that would be 108 degrees. So I know that X is 108 degrees. All right, now that I have X, I could probably find the vertical angle, but this one's kind of a weird one because look at it. It's split into two separate angles by this thing here. So let's start with what we know. Well, we know that this whole thing right here, see that? That whole thing is going to be 108. But it looks like they stuffed in a right angle in there, which means 90 degrees. So I'm going to have to go with 108 minus 90. And that should give me this little piece that's left over here. So that would be 18 degrees, which if you ask me, that does not look like 18 degrees. 18 degrees would be much, much smaller. But again, all right. Sorry about that. I need to, I just got an email from somebody. Maybe they're trying to get into the class. I was just talking about students adding in later. So that's probably what's going on now. So I just gotta add them in, let them know where to go. All right, until then, well, hopefully this shouldn't take too long. And that takes care of that. All right, let's go ahead and move on to the next one. So this part here says using algebra. It's the same thing, actually. You know, I could probably even just take these same directions here. Oops, wrong one. And put them right there. So these would be the same types of problems, and this one's gonna be a little bit different. All right, so find the measures of each angles. Keep the angle relations in mind. So we got about 4 more slides, and that should probably take us to the end. All right, so it looks like they're just talking about it. We don't have a picture, so we're gonna have to kind of make some of these ourselves. So angle 1 and angle 2 are vertical angles. If the measure of angle 2 is 105, find the measure of angle 1. All right, so in this case, we don't really need to draw a picture, although we could if we wanted to. And I'm gonna do both anyway. So first one here is, let's just think it out. So it says they are vertical angles, which means they're across from each other. If they're right across from each other, that means they are congruent. And again, vertical angles are congruent. So measure of angle 1 is 105 degrees. There you go. This first one was just testing to see if we know what a vertical angle is. Although we could have drawn a diagram, something like this, although it's kind of tough because we would have to draw something that's about 105 degrees. So it would probably look something like this. Right, so that's 105 degrees. Since they're vertical, they're gonna be right across from each other. But again, we didn't really need to draw the diagram because, you know, just knowing the definitions, we should be able to get it. All right, A and B are complementary angles. If the measure of angle A is 42, then find the measure of angle B. All right, so this one's pretty much the same one, or not really the same one, but it's similar. In fact, I think all of these are gonna be kind of similar. Ooh, man, just looking forward to being able to sleep in every day. All right, complementary angles. So remember, complementary means that they are 90 degrees. So I don't know if this is exactly the way it should be. And we don't know which way they're facing or anything like that. So we're just gonna have to assume, you know, the top one could be the small one or the bottom one could be the small one. but we know it's about 42 degrees, so it's almost in the middle. So this is like 42 degrees, and this would be whatever's left over, because remember, 45 is right in the middle. And it doesn't have to be perfect. In fact, most of them are not even that perfect to begin with. So we'll say that this is angle A, and this is angle B. But again, you could probably do this without the diagram. I'm just showing you, thinking about it, thinking about how you would do it. You would know that a complementary angle is 90 degrees, and we are going to subtract 42 using angle addition postulate, because both of these need to add up to 90. And I could probably do this one pretty easily too, but I'm kind of lazy today. And that would be 48. So now we know measure of angle B. So lowercase m, measure of angle B is 48 degrees. So we just type it, well, in this case, write it. So we're just going to write it the way we should. And that's the way you should write your answer, get into the habit. Okay, so I know a lot of people are going to be like, well, can't I just say 48 degrees? I mean, you already know the question. Can't I just be able to answer it? All right, but that's the way it should be. All right, I don't make the rules. I didn't invent math. All right, so that's it for that one. Let's move on to the next one. P and Q are supplementary angles. If the angle of Q is 64, find the measure of angle P. Okay, so let's see. We know that they are supplementary. And remember, supplementary means that it completes it, right? So just to think about it in terms of like everyday common English, supplementary is like a like when you say when you need something to complete something, okay, like say I don't have enough desks. All right, that's not a very good example because nobody would say we need supplementary desks, because if I have 30 students and only 25 desks, then those extra 5 desks would be supplementary. The only example I can really think of is like troops. If you don't have enough troops or soldiers in one area, you might say we need supplementary troops. So that's bringing it to where you think it should be to take care of what you need. But yeah, supplementary just means to complete it. So that's, again, a way to remember it. All right, so we know that, oh wait, I haven't even finished reading it. So if the measure of Q is 64 degrees, find the measure of angle P. So supplementary, again, means that they're going to add up to 180. So I just got a straight line here, and I'm going to mark just the spot anywhere is good. And again, you don't really need to do this. You could just go straight to the 180 minus 64. But to draw a diagram, I'm going to go here, and that 60 is about right there. Okay. And if you want to draw a 60-degree angle, just think of an equilateral triangle. Equilateral triangles, if you can get these two sides the same, they're going to be about 60 degrees. So I tried to go a little bit higher than that, so that way the triangle is a little bit more pointier. Not a big deal, but not at all a big deal. And like I said, you could just go straight to 180 minus 64, and that should give us our angle P. So in this case, we got 116. So P, actually, I think we're ready to write our answer out. So I'm going to say the measure of angle P is 116. All right, and last one for this page here, and then, like I said, we have, maybe I might pick up the pace a little bit. Well, we did start a little bit late today, so if we go a little bit over, we're 8:50, I think we'll still be fine. So angle 1 and 2 form a linear pair, and I'm going to start in the middle, because again, you could have this anywhere. If the measure of angle 1 is 113 degrees, so there's 90 degrees, and 90, 113 would be like right there. Again, we don't need to draw this, but it's just there to help you think about it. So here we have measure angle 1, angle 2. Find the measure of angle 2. Since we know it's linear, it's got to add up to 180 degrees, which means that, you know, if this is 180 degrees, we take away this one here and we'll be able to find the other one. So 180 minus 113, that's going to be 67 degrees. So measure of angle 2 is 67 degrees. And that's it for that one. I want to get as far as I can with these ones here. I think with this one, it just took a little bit longer just to draw the diagrams. Looking at these ones here, it looks like there is a diagram. So since there is a diagram, it probably won't take as long. All right, hopefully everyone copied that down. I usually try to give a few seconds, you know, in case somebody's still writing it down. And again, I know there's a big issue with the packets. I didn't talk to McCabe this morning, the principal, but I did hear her saying that the mail, you know, as always, you know, it's no secret the mail takes a while. So the best way, again, I'm going to remind you, if you don't have the packet, the best way to do that is to just sort of make some time, find a way to get here into town and have your packets picked up. All right, it is something that's going to take a while, but it's a lot better than waiting, like, you know, up to a whole 7 to 10 days waiting for your packet. Sometimes, I mean, sometimes they're pretty good about it. Sometimes they'll just be like, okay, well, you know, immediately let's just go and get the mail. The mail's sometimes good, but lately they haven't been that good, actually. In fact, I ordered like 2 things on eBay or something like that, and it's been more than a week for them to show up, and they should have been here like 2 or 3 days ago, but they're still just hanging around in the mail. Ooh, I'll be right back. All right, my battery was low, so I had to plug in my computer. This computer is kind of weird. It'll be like, oh, warning, you're at 20%. Okay, I'm gonna shut off now. So I gotta make sure it stays fully charged as much as I can. All right, so where we at? Measure of angle P, Q, T. No, so P, Q, T, so that's this angle here, just highlighting it, is 3x plus 47, and SQR is 6x minus 25. And again, you don't have to write this down, but I'm gonna write it down because it's not that quick, or it is a little bit quick, and okay. It doesn't look like we really need much. And for this one here, I'm gonna use purple to kind of show the angle that I'm looking for. This way, it's just a little bit of a help to know what I'm looking for. All right, so what do we know about these two things? Well, they're vertical angles, and vertical angles should be equal to each other. So I'm gonna just set them equal to each other and then solve for what x should be. And again, we're gonna use our basic rules of algebra, and I wanna keep the x positive. And in geometry, you know, like if you're in algebra, you're dealing with a lot of negatives and positives. But in geometry, you're generally dealing with things that can be measured. So it's usually not good. Okay, you can do it, it still works, you'll get the right answer. But it's usually a lot easier to just stick with positive, okay, positive numbers, because you can't have negative angles. Well, you kind of can, but you know, that's something else and almost entirely different. All right, so let's see what we got here. 47 plus 25, and that's going to be 72. So 72 equals 3x. So what times 72? Well, I know this one right here. I was going to use a calculator, but I know this one right off because I know 3 times 25 is 75. And 75 and 72 have 3 different, so that means minus 1. So 25 minus 1 is 24. All right, so that helps me know what x is, but remember it says what is the measure of SQR. It doesn't say find the measure of x, it says find the measure of this thing here that I highlighted in purple. So let's go and take this, which again, both of these would work. Okay, both would work because they are vertical angles and they're congruent. But I'm gonna just stick with the one that is given to us. So 6x minus 25, take out the x, plug in what we know x is, and we know it's 24. 6 times 24, it's like 144 minus 25. And that gives us 119, which, does that look like 119 degrees? Yeah, roughly. And again, you shouldn't trust the diagram, but in this case, it looks like it is pretty close to what it should be. And I'm running out of space. I know sometimes, like if you're, sometimes this area is blocked off. You can't see it way on the right. So I'm gonna just use this as the answer. So measure, let's see. It looks like I'm gonna have to start kind of backwards. SQR, measure of that. All right, you don't have to do this. I'm just doing this because sometimes in the video, the far right part is blocked off and you can't see it. So I got to be considerate to those people. All right, let's see. AB, so this bottom line is perpendicular. Remember, that's the sign that means perpendicular. It looks like a little flag poster or something. Is perpendicular to DC or CD. So measure of DCE, so that's this top part. And again, you know, whatever helps you out. You can fill this in, or if you're pretty good at keeping track of all these things in your head, don't worry about it. And it says measure of ECB, so that's this tiny angle down here, is x plus 8. Find the measure of DCE. All right, so we're told it's perpendicular. Right, so we can put a little box there if it helps us. And we know that if this is a straight line, which it does say right there, line AB, that means this side put together is also going to be 90 degrees. What the heck? All right, I don't know. If it was work related, I'd probably answer it, but I don't know. Someone from Flagstaff. Trying to remember if I left anything in Flagstaff. You know, like a car to be worked on or something. I mean, the mechanics here are pretty good. CALS is okay, you know, but if it's anything that's going to take a while, you know, I try not to let CALS do it. Not that I don't like them, it's just they're always overworked and they always have a bunch of cars, and it's like, you know, a lot of times I'd rather just drop it off and have it done. But like, I'm talking big jobs. Okay, put the excuse me, put the like terms together, right? They're both x's. And then here I have 2 regular numbers, 2 and 8. So I'm going to put those together. And let me see. This one's pretty easy. X is equal to 10. And I'm going to try to keep it here so I can, if I need to work on one of these again, I can go ahead and plug it in. So like here, I almost ran out of space. Although the lower I get, the less it matters, because it probably only goes about right there. Let's see, what am I doing here? I need to plug it back into DCE, which is this one right here. So again, I can easily just look at the diagram. I don't have to go reading the whole thing again, which reading the whole thing is not really, it's not way more difficult or anything like that. But if I can make something even just a little bit easier, I'm going to do that. So there we go. I plugged in 10 because we know that X is now 10. And we should be able to write our answer. So measure of angle DCE, and make that a little bit straighter so it looks like, kind of look like O for a second, is supposed to be 72 degrees. And I'm able to write the whole answer right there. Oops. All right, and that's it for that one. Let's move on to the last one, which is this one here. Well, not the last one. We still got a few more to go. So let's see, KNM. So KNM, 8x minus 5, and then MNJ. MNJ, so that's this one down here, 4x minus 19. Find, excuse me, find KNM. All right, so it looks like we're going to find this one, so it's going to be kind of the same thing. We just got to know which one to use. Now we know that these are a linear pair, right? They're adjacent, meaning they're right next to each other, and they both form a straight angle, straight line. So that means that this added to this should come out to about 180. Combiner like terms, so 12x and 4x, I'm sorry, 8x and 12. 8x and 4x is 12x, sorry. I have a habit of saying things that I'm writing. So usually if I have to say something, I'll usually write it and then say it. And I'm just using my basic algebra here, so I'm going to add 24 to both sides. And that should give me 12x equals 180 plus 24, and that's going to be 204. And then divide that by 12. Remember, that's not the actual angle. It's not 204 degrees. It's just whatever they put x to be. So in this case, x comes out to be 17. All right, now that we know that x is 17, we're going to have to plug it back in here because remember, we're looking for k and m, which is this piece right here. So 8x minus 5, but again, replace that with 17 minus 5. So 8 times 17. What is 8 times 17? Okay, best to just use the calculator in this case. And that'd be 136. If I multiply those together, 136 minus 5, and it's going to be 131. I think that's it. I think that's what we're looking for. So measure of K N M equals 131 degrees. Okay, and again, we started a bit late. If I remember, we started like 10 minutes late. So I'm hoping I can get to the end of this slide here, and then we'll continue because I'd rather just be done with an entire thing and then break it off there instead of I don't know, instead of kind of just stopping at a weird spot. And as always, I'll give you a second or two to write this down in case you're still following along. Okay. And if you ever need to, don't forget there's the video, or if I need to go back, you know, we can always go back after the thing. You know, I don't want to leave anybody behind, but at the same time, it's like I know sometimes it's just there's just like one person that's kind of still writing this stuff. All right, so what do we got here? So same thing, same directions. The directions haven't changed. We still got to find out what they're looking for. So find the value of x and y. Uh-oh, looks like we're going to have two things to look for in this case. So DEG, 5x minus 4. GEF is up here, so that's going to be 7x minus 8. DEH, so that's going to be this bottom one, 9y plus 5. Find the values of x and y. All right, let me think. This one might not be so tough because we have a lot more things to work with. So looking at it here we have a straight angle, right? So those two should add up to 180 degrees. 7x minus 8. Seven x and 5x. Make sure I put them together correctly. Oh yeah, and anytime you notice something's not right, if like you notice I put in the wrong number or made a mistake somewhere, don't be afraid to let me know. Okay, it's happened. It happens. I don't want to say a lot, but it's way better than getting to the end and then I'm like, wait, why doesn't this work? And then looking over the whole thing and being like, oh, okay, now I see what happened. 192 divided by 12. It's going to be 16. So x is equal to 16. So now we got the first one. We got x. Now we have to find y. Now, and with this, there's two things we can do. I could do the same thing with these two angles, set them equal to 180. So I'd have 5x minus 4 plus 9y plus 5 equals 180. But then substitute x as 16. So that's one thing I could do. The other thing I could do, which is probably the easier thing, is use the vertical angles, right? So if I know what that 7x minus 8 is, then this should be the same as that, right? Because they should be equal to each other. So that's probably the easier thing to do. So I'm going to go with that one. 7x, but replace x with 16 and work that out. And that should give us what we're missing. So 16 times 7. Going to be 112 minus 8. And it's going to be 104. And I think that's it. I think we're done. So write out the answer, measure of angle. Oh, wait. Actually, you know what? I guess I was wrong. I guess that's not the easiest way to do it because I know what the segment angle is, but I actually don't know what y is. Oops, my bad. 104 equals 9y plus 5. I'm going to have to plug it back in and solve it. So I guess I was wrong. It's only because I was looking for the total angle and not the whole thing. But luckily, even with that, I can still work out this problem. And it still is not that tough. Just use your basic algebra, set it equal to each other because, again, we know that this is 104 and this y should substitute in for 104. So now we know that y is 11, and I'm usually not into a big, I'm usually not into, if I'm in the class, I usually don't jump off with what I'm working with, because you guys are what I'm working with. But since this is the first week, I'm still having students looking for the class. Probably after this, if any internet thingies or anything comes on. So next week it'll be a little bit smoother. I'm gonna just stick with the lesson because by now everybody next week should know where to go. All right, we'll do these two and then we'll be done for now. I thought I could get to the end, but some of these, you know, it's kind of hard to tell how long they're gonna go. Some of them, you know, use a lot of information. Some of them are pretty simple and straightforward. Let's see, R and S. Okay, so angles R and S are complementary angles. So again, that means they add up to 90 degrees. And in this case here, there's no diagram, so it looks like we're gonna have to either make our own or work it out. But again, thinking about it, well, in this case, let's try something different. Let's try not using a diagram. So we know they're complementary. So we know that R plus S equals 90. We know that R, right in here, so there's our R, is 12x minus 3, and S is 7x minus 2. And these two together should equal 90. So 10x, oh no, that's not the one I'm looking for. I need, that would be 19x minus 5 equals 90. And again, I'm just using basic algebra here. 95 divided by 19 would be 5. And just a heads up, so far, looking over the packet, I don't think there's going to be very many decimals. So if you get a decimal or a fraction, you might want to double check it. I'm not saying it can't happen, all right? I haven't looked at the whole thing. Again, this is my first time in 6 years teaching geometry, so I don't know exactly what to tell you, but yeah, if you get a decimal, just be a little bit, just worry a little bit about it. All right, so find the measure of angle R. So we want the angle R. And again, diagrams are a little bit easier. You can follow a diagram a lot easier. Right, because if you're looking at this, you're probably thinking, where did all these numbers come from? Well, again, it says R, so we're trying to find measure R. So we take R, we know that X is 5, so plug that in, evaluate it, and then that's what we get. We get 57. So measure of angle R equals 57 degrees. And in this case here, like in this one here, we didn't need to find the degrees, right? X is not 16 degrees. It's just, for this one here, X and Y are not degrees. They're just numbers. All right, last one for now, and then we'll kind of take off from here for the next one. Just so we stay with the scheduled times. P and Q are supplementary, which means they are 180 degrees. So this 4x plus 1, P and Q should add up to 180 degrees. And they want us to find the measure of angle Q, so that's going to be this one here. So once we find out what X is, we're going to have to plug it into that one. So let's see what we got. 9 and 4, that's 13x. Take care of our like terms. 1 minus 3 would be -2. That'd be 180. 13x. And then I'm going to add 2 to both sides, so we get 182. (182) divided by 13. And it's going to be 14, so x equals 14. But it says find angle Q, so grab our Q, which is 9x minus 3. But take out the x, put 14 in there. So times those together, we get 126 minus 3, which would be, and from here I'm ready to put the answer in. So measure of angle, and I want a Q, so let's give it Q. Measure of angle Q equals 123. Because we still got a -3 from it. And I know it's really scrunched in there, but we managed to get it in there. All right, so that takes care of the Zoom lectures, what they call it, Zoom session. And just to simplify things, again, if you have the schedule, I think it came out with some of the packets, or if not, you can find it in the mail, but you don't really need it, okay? It just helps you kind of plan your day. As long as you stay with the Zoom most of the day, then it should be fine. So for this one here, I just call it the big break. And that big break will continue till 9:45. So you have the next 45 minutes kind of to yourself. But please use this break wisely. Okay, so if you're doing the homework, you're needing to, you know, because there's the in-class work and then there's the homework, right? So those are the two things that you got to worry about. Right now we just did the in-class work, and then if you were to go over to, I'm going to switch screens here, so sorry about that. So this is what we did here, right? And this is exactly the same thing we did. Wait, hold on, this is not exactly the same thing we did. Okay, yeah, it's looking familiar. But the only thing is we stopped right about here, I think. Oh, right here, we stopped about there, the 123 degrees. We still have a little bit more to go on this one here, but we do have a few more slides left over. So that's the in-class work. This is the homework, and it's labeled right there, homework. So if you have a, once you have all the in-class stuff, you should, you know, that the homework is the part that you do on your own. And that's for me to kind of tell how well people are learning. But like I said, we'll go and stop here and we'll resume at 9:45. I'm not going anywhere. I'll be in the room. So sometimes I may not be in front of the screen, but you know, if you need to get my attention, just turn on your mic and let me know, or leave something in the chat. All right, so again, this is just gonna be a break. I call it the big break. Okay, bye for now.